PSI. To change the pressure, we pull the knob out, and we can rotate to decrease the pressure, or we can turn the other way to increase the pressure. All of the knobs work in the same fashion. The next one down is for the outfeed rollers. These are the two rubber rollers at the end of the machine. Going down from there are the infeed rollers. These will be the steel rollers before the top horizontal head. And the very first infeed roller, just below that, will now have its own separate pressure, so we can regulate and possibly not flatten the board too much for straightening operations. Directly below that, we have two more switches, and these are used when straightening is absolutely critical. The one on the right will disengage the first feed wheel, and the one on the left will disengage the first side pressure roller. These will ensure that we don't mechanically flatten the board when we want to do some straightening. The final control that we're looking at is the feed speed indicator. We can control our feed speed by turning this black knob to the right or to the left to increase or decrease the feed of the material going through the machine. We have two scales, as we can see here. The white one is in meters per minute, and the green one, which what we're interested in, will be in feet per minute. Keep in mind, the only time we adjust our feed speed is when the feed motor is running. Directly below the control panel, we have the controls for the in-feed fence and the in-feed table. This lever here, once it's loosened with a quick twist of the handle, will raise and lower the in-feed table. This will control how much stock we remove off the bottom of the board, from 0 to 3/8 of an inch. The next handle controls the in-feed fence. We twist it to loosen the lock, and we can move this in and out like we see here, and this controls how much stock we remove on the right side of the board with the right head. This also has a range of 0 to 3/8 of an inch. Here we're on the side of the electrical panel. This is our main inlet for our air supply, and then it travels to our shutoff valve, which allows us to cut the air supply off very quickly and easily. Directly after that, we have our pressure sensing unit. This tells the machine when the air is on and when it is not, and will shut the machine off if we lose air pressure. The next thing we have to adjust is this reference engraver. This is an additional cutter right next to the planer head, and this cuts a rabbet in the side of the board, and this is what allows the right side of the board to be cut by the right head. To adjust this reference engraver, we have to look at this short little reference fence. We take our straight edge, and we align the cutters so they're perfectly even with the outfeed portion of that little short fence. What we're looking at here is the right vertical head. This is the head immediately after the first planer head. The adjustments for this head are directly in front. To adjust for the cutting circle or the diameter of the head, we use this digital readout on the right. That will move the head in and out in relationship to the outfeed fence. The next one on the left is for my axial positioning. This is the vertical movement up and down of this vertical head. The locks for these two devices are directly below this digital readout. Here we have another view of the right vertical head. Immediately after the right vertical head, we have the fence. Now you notice we have a rather large gap between the fence and the cutter head. Here we'll show you how to make an adjustment to bring this gap down. Directly behind the fence, we have two 17mm screws. Loosen the two screws, freeing up the fence, and now we can slide the fence forward, getting it much closer and giving us positive support for the workpiece. We want to get the fence about 1/8 of an inch from the cutter head. Now we see our left vertical. It's similar to the right vertical in that it has the same two types of adjustments, but this one has one additional adjustment. The left vertical also controls the final finish width of our product, and that is done with our hand crank on this shaft all the way to the right. The first thing we do is we loosen the locking mechanism directly underneath here, and then we can crank in the head in and out as necessary and change the final finish width. The digital readout on the top has its own locking lever, and that can be released from this position here. This will be our minimum cutting circle, and this will realign everything to the new cutter head. The side pressure, the chip breaker, and the outfeed support fence will all be realigned to the new cutting circle. Directly below that is our axial positioning. This is what moves the head in an up and down fashion or a vertical fashion, and the lock for that is directly below with this handle here. Now when we turn this handle, the spindle and the cutter head will move up and down, positioning the profile precisely where it needs to be. What we have here now is the LED readout, which represents the thickness of our product and also the width of our product. This is an exclusive SCMI feature. You're going to find that these are much easier to read than mechanical digital readouts, and the big key factor here is that they automatically recalibrate whenever we change our cutter heads and we input the minimum cutting circle. If we find that our bottom head needs to be readjusted, that can be done with this crank directly below the first bottom head. First we loosen the lock, and then we can turn the crank in either direction, raising and lowering the head as necessary. But always remember to stop with the head going in the up position to take advantage of the lifting screw holding the head in position. Directly above that, we have the adjustment for the axial positioning. This will position the reference engraver to the fence, but first we need to loosen our axial lock. Here's another view of our bottom horizontal head. If we find that we need to make an adjustment for the reference engraver in relationship to the reference engraver fence, the first thing we need to do is loosen the axial lock. That's what locks it and keeps it from moving from side to side. Directly below the second feed wheel, which was removed for better viewing, you'll find the axial lock, which is located right here. It's a 19 millimeter, and when we put our wrench in place, we loosen it, and then we go to the adjustment rod located directly below the first bottom head to make the necessary adjustments. What we're looking at now is the top horizontal head. This head has two primary functions. Not only does it finish the top of the board, but it also determines how thick the piece is going to be. Directly in front of the top horizontal head, we have the pneumatic chip breaker. Its function is to hold the piece down in place while it's being machined, as well as ensuring that the chips get broken off and sucked up into the dust collector. Immediately after the head, we have our outfeed hold-down shoe. This hold-down shoe has two primary adjustments, and they're controlled by this knob on the top. If we turn the knob, we'll raise and lower the outfeed shoe. If we turn the screw directly below the knob, we'll increase or decrease the amount of pressure on the outfeed shoe. Now directly above the cutter heads, we have two mechanical digital readouts. The first one on top has a locking device on the side and can be adjusted with our hand crank. The information we put there is the minimum cutting circle. This will readjust the machine to the new cutter head. This will readjust the feed wheels, the chip breaker, the outfeed shoe, the outfeed wheels, as well as recalibrate our measuring device. Directly below, we have the digital readout for the axial positioning, or the horizontal positioning of the horizontal spindle. This will align our profile exactly where it needs to be aligned. The locking device for this axial positioning is directly above and to the back of the machine, in this area here. This would be a good time to talk about proper head installation. The first thing we do is we slide the head till it's totally seated. Then we install the proper amount of spacers to make sure that we can secure the head properly. If we find that the last spacer we put on is a thin spacer, we need to install it behind a thick spacer. And the reason is the end of the spindle assembly is slightly smaller than the rest of the shaft, and the small spacer will not seat itself properly. When we turn them around, this eliminates this problem. Now the key ingredient here is going to be having the spacers in the proper relationship to the end of the shaft. The end of the shaft is machined with a shoulder, and this spacer must extend past that shoulder. Otherwise, we're not securing the head properly, and we have the chance of spin welding the head onto the shaft. Here we're going to install our locking ring. The locking ring has a keyway, and it has to match with the keyway on the shaft. And now we'll install the locking bolt. We'll screw this till it's finger tight, and then we'll take our bolt locking wrench and we install it. This has to fit in two positions, on the hex and also on the gear. Once we get it installed in the proper position, this long handle will then rest against the solid part of the molder. and the short handle is the handle that will turn to lock the nut into position. The long handle can rest against any part of the molder with the exception of the mechanical digital readouts. Now we're at the final outfeed end of the machine, and here we're looking at the last bottom head. Directly below that we have our adjustments for the last bottom head. The digital readout on the top is for our axial positioning, and this controls the horizontal movement of this horizontal head. This way we can align the profile exactly where it needs to be on the workpiece. But before we can make this adjustment, we have to loosen the axial lock, which is directly behind the outfeed roller. It's similar to the axial locks we talked about before, a 19mm hex. Directly below that, we have the diameter input for this last bottom cutter head. Here we measure the cutter head, put the diameter, and it automatically adjusts it to the table height. Before we make our adjustment, we loosen our lock, put on our wrench, and make our adjustments. As we move down towards the bottom of the machine, we have another large control knob. This is the fine adjustment for the workpiece thickness. Once we use the motorized positioner to get close to our workpiece thickness, we turn this knob to get our final adjustment and to get a precise setting. Towards the end of the machine, we have a machine surface which is designed to accept the universal head if and when we put one on in the future. Let's talk about the last outfeed head a little bit more. There are two ways to do our machining. One way is to machine only a portion of the bottom of the board. For example, if we're doing a casing and we're only doing the relief part, we can then just use our straight edge, raise the cutter head into position, and then be ready to run our board. If we want to machine the entire bottom of the board, we have to do something a little bit different. We'll take out our locking bolts, and then we'll raise the table a little bit by using our 15/1000 piece of shim stock. We put this in place, return the locking bolts, making sure that we secure them, and now we'll use the same straight edge and raise the lowest portion of our cutter even with the outfeed portion of the table. This will raise the cutter head just enough to make up for the amount of stock that we remove from the bottom. Now, still at the outfeed end of the machine, and keeping in mind that our end panel has been removed for visibility, we're looking at our outfeed table rollers. These outfeed table rollers from time to time will wear and get a little bit smaller. Then they'll work themselves below the table surface, rendering themselves inoperable. So from time to time we have to check the height of these rollers, making sure with a straight edge that they're slightly above the table height. When we need to make an adjustment, the adjustment screw is directly in line with the outfeed rollers behind the fence. We have a 5mm Allen wrench that'll raise and lower, but first we have to go behind the fence and below it to loosen a 17mm jam nut. Then we can raise and lower to our satisfaction. We just got through talking about the adjustments on all the heads of the Superset 23. There is one more thing you need to know about. Whenever we make an axial adjustment, that's going to be the vertical adjustment of a vertical head or the horizontal adjustment of a horizontal head, we need to spin the head at the same time we're making that adjustment, as you can see here. This is the right vertical head, and we're raising it up, and we'll spin the head at the same time. If we fail to do this, we'll stretch the belt, tear the inner fibers, greatly shortening the life of the belt. Now we're in the back of the Superset 23. Let's talk about some of the important adjustments that we'll find back here. What we're looking at now is the feed motor on the left side of the back of the machine. The motor is located on top and has a series of pulleys and a cog belt. Just below the motor is another shaft with two grease fittings that need to be lubricated every 2 weeks. What we're looking at now is the grease fitting for the first bottom head. What we have is one on the left side and two more on the right. What we're looking at now is the motor which drives the first bottom horizontal spindle. This is located directly below the feed motor. Slightly above this motor we have the plastic shield which protects the drive belt. In order to replace the belt, we must first remove this shield with two screws, one on either side. Once we get down to the motor,